Why are we up here?
We're asking that the same way.
I don't develop games often.
But when I do.
Should I count you in or what?
Are we in? Are we good?
No, well, yes.
Where's our?
Now, I mean, you're moving now.
Where's our zones? Sorry.
Okay. So, if you want to move to the right, I can show you where the end of your zone is.
Your right or my
My
right?
right. My right.
Stage right.
Yeah, like right there. Don't go any farther than that, and then don't go past this podium. Yeah,
Okay.
So, you ready? 5, 4.
Hello, my name is Chris Hamilton,
I'm Jason Ryan.
James Bird.
Lauren Smith.
and we are MJ and Air. We have we originally got pitched a research project to develop a tablet-based tool that allows you to manipulate a quadcopter, a physical real quadcopter in a real environment, but represent that on the tablet so that you can manipulate its controls and such in that manner. The game itself has a front GUI screen, and you can also go through the controls, the credits, the settings. And we threw a little spin on this. So instead of just making it a research project, we gamified it a bit.
And we give it a nice story.
Yes.
Start. There we go.
Okay, now the object of the game is to, well, what you as the, if you were actually the research professor, so using the tablet, you're going to draw out your lines on the screen to map the location of the quadcopter itself and where you want it to go. And on the game side, we do have some objectives that you obviously don't want to hit the giant bees, and you want to make your way through the room, through these batteries to get extra, to get energy to be able to keep continuing through with your copter, and also you get points as you traverse across the game itself. And I'm going to hand this over to Jason and allow him to talk about the directives.
All right. So the next thing we had is these things called directives, which Professor Finikos was very happy to see. If we switch over to a different view, this is the copter view, and this is the directive editing view. So when you're in this view, if you can see the directive over here, we can click on it. Sometimes
One of the things we worked on overcoming was making this work on the tablet. Because the version of Android that the tablet has on it and its specifications don't work very well with Unity.
Oh, no. So yes, normally when you select them, they would just pop up a little menu that allows you to edit a lot of different data on them. If I go to the top, I can just drop a couple more and it'll be fine. So the idea with the directives is that you're able to change the data that the copter is currently running off of and basically change the way it's moving throughout its space.
This allows, from the research standpoint, allows you to alter the state of the quadcopter itself between directives. If you have, let's say, an obstacle like wind, heavy wind, or something like that, you can edit the speed and the direction and such before the copter actually gets there.
Right here you can see it's got its position, its look vector, the archetype that it's currently using for the rest of the curve that this directive is attached to, the length of that line, the speed at which it will traverse that line, and the wait time it'll take before it takes that line's distance. It also tells you the number of data points that line currently holds. That's just a number of points in space. And so you can change any of these except for the data points. You'd have to do that through drawing. You can change the speed to go super fast. You can make it wait a couple of seconds once it reaches this one. You can make it so that this aligns to look straight. See, now it's firing a straight line. You can change the direction it looks. Then if we go out of this view, you can go on to start it. And first we're going to up our speed from 0 to 1. And you'll notice the world comes to life. That's by a time factor. And now you're actually dealing with moving obstacles. It's like then when you hit the start button, the copter begins to traverse it. Right here, we haven't drawn the optimal path. So you see at the top right, there's a battery bar, and our copter's going to die pretty quick.
Yep. And also, as it traverses, you get a score value that increases based on the number of, it's got grids on the back end of it that it's calculating throughout the whole map. So as it traverses those grids, it gives you a points value. So that's pretty much the game itself in a nutshell. James will actually talk a little bit about some of the game points and things. So
Yeah, okay. So we obviously had a little bit of fun setting everything up. I mean, a bunch of giant bees in the kitchen, but everything sort of has its own purpose in this research-based environment, because the kitchen offered multiple varying of environments and interesting obstacles, and it kind of pushes us to be creative in the way we draw our lines. And so the purpose of the bees is obviously a moving obstacle that you'll have to think forward to avoid, and you'll have to stay out of their course. Same with the perpetually moving pan that was designed as a regulation of speed test, so you'll go up to the pan, slow down for the appropriate amount of time, then go through it. Yes, there it is right there. And so that's kind of how we designed our levels to really work well with the interface that we figured would work best controlling a copter.
And Lauren, would you like to talk about some of the models you made?
Well, I made the helicopter quad, or air drone, I suppose you can also say, and along with the bees, and a couple of the kitchen appliances that are set throughout the level. And so some of the animation was done by me, but there was like the coding animation done by him, and so that the bees can actually go around in a predetermined path. And I also helped create some of the textures that occur on the opening menu screens. And it was all a lot of bunch of contribution from everyone just to get everything running and get onto the tablet.
Yep, and so the biggest objective we had here was the research side of it, drawing the lines, being able to manipulate directives, and being able to control the copter in a controlled environment. So if you had a room such as this one that we're in, you could actually view the camera that's on the copter itself directly in the tablet to see where it's going and kind of what obstacles may be in its way. I think we hit that point pretty well. The second one was to gamify it. We added a scoring system, we added an energy bar and some obstacles, so I think we did pretty well on that one. Once we actually went from the computer to the tablet, the issues that we had on that side, we were able to actually overcome a lot quicker than I thought we would. But unfortunately, the speed and kind of ability of the tablet itself, there was really nothing we could do with that. It's what we were given. So, but I think we did pretty well. Thank you very much for coming. At least somebody understands what's going on here.